In this quick video, we're going to look at how HDP, AtScale, and SyncSort combine to make analytics fast and easy on Hadoop. People use Hadoop because they want analytics on big data, but they want it to be fast and they want to use their favorite tools to do it. In Hadoop, Hive with LLAP in-memory caching creates the core foundation of fast SQL that scales to any data size. Since analytics runs on data, the first step is always to import data from an existing database. This is where SyncSort's DMXH comes in. SyncSort gives high-performance connectivity to every major database, including Teradata, Oracle, SQL Server, and more, and it makes it easy to bring data into Hadoop using a graphical drag-and-drop UI or a command-line interface. Then we have AtScale. AtScale layers on top of Hadoop and Hive to create a virtual OLAP cube that pre-aggregates data for 10x faster queries, so big data analytics go faster than ever before. AtScale also supports the most popular BI tools like Tableau and Excel, and since AtScale is a layer on top of Hadoop, users can still access the full fidelity data whenever they need to. To start off importing data, here we are in the SyncSort DMXH UI. You can see this is a simple graphical way to import data, filter it, sort it, and many other operations, and it makes it simple to bring data in from any existing data source into Hadoop. So in this workflow I've set up, I'm copying data from a source database, I'm filtering it, I'm sorting it, and then writing it out to Hadoop. If I want, I can go in here and edit my filter condition to say only import data that from my source table for dates beyond, let's say, 2005. Okay, I can save that away, and I've changed my filter condition. So in this way you can see this is a very simple graphical UI. It doesn't require any deep Hadoop expertise or deep expertise with source EDW systems. And for additional automation options, SyncSort also lets you import data in bulk using a command line tool called Data Funnel. Now for the next part of the demo, I've loaded my Hadoop cluster with data for all flights in the US between the years 1988 and 2008. Here we are now in the AtScale Cube Designer, and we see all the data that's been loaded into Hive, flights, airports, and so on. The flights table you see here records facts about every US flight. Now we know our users want to get a deep understanding of flight delays and their causes, so they're going to spend a lot of time looking into average and maximum delay times. Since we already know this, we can pre-aggregate this data so users aren't sitting around waiting for it to happen on the fly. In AtScale, we do this by dragging the departure delay field into the measures area and choosing the type of aggregation we want. In this case, I'll choose the average. Now, having done this, AtScale is going to pre-compute the average departure delay across every dimension. Next thing, our users are going to want to know which airports have bad delays, what cities, what days of the week. They're going to want to drill down across a lot of different dimensions. So to support that, we're going to take this airports table and drag it into the dimensions section, and then link that up to the fact table using the associated key. In this case, the fact table says the origin airport. I'm going to link the origin airport to the airport's dimension. From here, I'll be able to navigate into cities, into states, into countries, and so on. Within AtScale, I'm able to actually define that entire hierarchy so that my users sitting in their tools will be able to navigate all the way down from the country to the state to the city and so on. Now, a fully fleshed out OLAP cube is going to have a dozen or more dimensions, at which point you would publish this cube out and make it available to your BI consumers. To save time, I'm going to switch over to a finished cube and show the BI experience directly. Let's use Tableau to connect to that cube we made. This connection is in real time so that this is what an end user would actually see. The first thing to note is that everything we define in AtScale is right here in the UI, so users don't have to discover data or link it together themselves. They just connect and go. But can we do all the analytics we need, and is it fast? We said we wanted to understand flight delays. Let's start by looking at average flight delays for the top 100 busiest airports broken down by state, red being the worst, green being the best. Some states have much worse track records than others, but a state can have many airports, so which airports are the problem and which are not? AtScale lets me define a hierarchy to drill down from country to state to city. So let's use that now by expanding the hierarchy. For example, Texas has a number of airports, but we can go within the state, expand the hierarchy, and see the specific cities that have the problem. For example, we see Dallas and Houston have problems, where cities like Austin less so. So now we know where the delays are, but what are some of the reasons why? So for the next thing, let's take a look at a map that shows us the top 50 busiest routes in the country. We see a number of cities like Denver acting as transportation hubs. Is there any relationship between busy routes and delays? So let's overlay that busy routes map with the average delay time for those airports. One thing stands out. These hubs have bad delays like Denver, but the endpoints tend to have much better records. Maybe a late inbound plane has a big ripple effect on the next flight. To see that, I've got one more field here called was delayed that breaks down if the inbound plane was or was not delayed. So let's take a look at that. This next chart shows average delays broken down by whether the inbound plane was or was not late. We see the difference is really huge. This blue line says planes were not delayed. We actually see the departure delay times go negative, almost 3 minutes ahead of time. When the inbound plane is delayed, the average gets pretty close to 30 minutes. A huge difference. So to sum it up, the combination of HDP, AtScale, and Tableau gave us the ability to analyze big data quickly and easily. HDP by providing the fast SQL and the deep storage, while AtScale boosts the performance by 10x through aggregating data ahead of time. Tools like Tableau make it easy to visualize and explore. To learn more about how HDP and AtScale make big data analytics fast and easy, visit hortonworks.com/HDP or hortonworks.com/partner/AtScale to find out more.